Good afternoon and welcome to this webinar, The Future of HVAC Refrigerants, Are You Ready? This event, brought to you by the ACHR News, is sponsored by Chemours and Rheem. I'm your moderator, Kyle Gargaro, Editorial Director of the News. Thanks for joining us. Chemours is a global chemistry company, a recognized leader in providing sustainable, low GWP refrigerant solutions and driving commercial readiness and the adoption of next-generation refrigerants in the HVACR industry. And Rheem is a global manufacturer of space heating, cooling, water heating, pool heating, and commercial refrigeration products, and the largest manufacturer of water heating products in North America. Today's presenters are Allison Skid, Senior Manager, Global Regulatory Affairs with Rheem Manufacturing, and Stephen Spletzer, Principal Engineer at Chemours. Stephen has spent over 2 decades of his career in HVACR applications, working for both equipment and refrigerant manufacturers. His responsibilities have included equipment design and testing, tech service and support, industry training, and development of educational programs, literature, and mobile applications. Now with Chemours, Stephen continues to support our industry through codes and standard activities, where he serves on a number of committees and working groups related to ACR systems. Allison is a chemical engineer and 20-plus year industry expert who has worked in production, supply chain, sales, marketing, and now currently in the government affairs space as the Senior Manager of Global Regulatory Affairs for the air business of Rheem. Allison is very involved in industry efforts to facilitate the safe transition to low GWP refrigerants at the state, federal, and international levels. She serves on multiple code bodies and industry committees, including Task Force for AHRI and Environment and Climate Change Canada. Don't forget to submit questions, and later in this program, our presenters will address as many as possible. Today's event is being recorded and archived on achrnews.com/webinars. And now I'm going to turn over to today's first presenter. Go ahead and take it away, Stephen.
Thanks, Kyle. And I want to thank everyone online for giving me the opportunity to talk to you today about refrigerants. But before we get to that, since it is Veterans Day, I just want to give a shout out to all our veterans and say thank you for your service. We hope you know how much we appreciate everything you do for us. So here's what we're going to cover today. I'm going to talk briefly about refrigerant regulations driving our industry, and then cover some background on the A2L Refrigerant Safety Group. Then Allison will cover why R454B, differences between R410A and R454B system designs. Then we'll talk about things technicians need to know going forward and some time for Q&A. So let's start with refrigerant regulations. Over the last several decades, our industry has been focused on solving the issue of ozone depletion by phasing out CFCs and HCFCs under the Montreal Protocol. These chemicals are both ozone depleting and have higher global warming potentials, or GWPs. We were successful moving away from these ozone depleting substances by transitioning to HFCs, or hydrofluorocarbons. Now, while HFCs are non-ozone depleting, they still have relatively high GWPs. And so our industry is now focused on addressing global warming through a global phase down, very important, not phase out, but a phase down of HFC refrigerants under the Kigali Amendment. Now, in case you're not familiar, the Kigali Amendment modifies the Montreal Protocol and establishes a framework for a global phase down of HFC refrigerants on a GWP weight basis, where essentially countries will have to reduce their HFC consumption through a series of step downs. Now, the Kigali Amendment entered into force January 2019, and so far about 128 countries have ratified it. But as of today, the US has not. So in the absence of federal regulation, a number of states decided to take matters into their own hands, and chief among them will be California through the California Air Resources Board, or CARB. Now, CARB has proposed a number of prohibitions on the use of higher GWP refrigerants in a broad range of applications. I just want to highlight a couple of critical end uses here that are of importance to our industry. First, CARB has proposed a 750 GWP limit for refrigerants in new air conditioning systems. This starts January 1st, 2023 with window units and dehumidifiers, 2024 for chillers, 2025 for most residential and light commercial systems, and finally 2026 for VRF systems. And what this means is that manufacturers will no longer be able to use higher global warming potential refrigerants like R410A in new air conditioning systems. Now for refrigeration, CARB has proposed a 150 GWP limit on all new systems containing over 50 pounds of charge, like for example, supermarket rack installations. And that would go into effect January 1st, 2022, which is right around the corner. But additionally, CARB has proposed that supermarket chains have to reach an average GWP level of 1,400 or less for their installed base of stores by January 1st, 2030. So with these proposals in place, equipment owners will likely want to move away from higher GWP refrigerants like R404A or R507, maybe retrofitting existing systems to products like R449A or XP40, or installing new systems with low GWP solutions like A2L refrigerants. Now, there has been some activity over the last year at the federal level, and the big one is the AIM Act, or the American Innovation and Manufacturing Act. This was signed into law in December last year, and the AIM Act gives the EPA the authority to administer an 85% phase down of HFCs on a GWP weight basis over the next 15 years. And this will help bring the U.S. into alignment with the requirements of the Kigali Amendment to the Montreal Protocol. Now, so far, the EPA has issued a rule establishing allowances for the production and consumption of HFC refrigerants in 2022 and 2023. We expect a second rule to come at a later date for 2024 and beyond. Additionally, in the near future, we're expecting the EPA to establish sector-specific controls. Now, these could take the form of GWP limits, similar to what CARB has proposed, but they may also consist of disapproval of higher GWP HFC refrigerants in applications where they were used before, similar to what was done under SNAP Rule 20 and 21. Now, the AIM Act also enables the EPA to set up guidance for reclaims, so we're expecting to see a ruling on that as well in the near future. One last item from the AIM Act I want to mention is that the EPA has put in place a ban on disposable refrigerant cylinders. Now, this is being done primarily to address the issue of illegal imports. Illegal imports of refrigerants most commonly occur in small disposable cylinders, and this has been a big problem for regions like Europe, making the HFC phase down there much more difficult. But there's also concerns that are being addressed, such as with waste. Now, the ban on disposable cylinders will go into effect January 1st, 2025, where manufacturers will not be able to fill new disposable cylinders or import them into the country. And we'll have a 2-year sell-through period where the stockpile of disposable cylinders has to be consumed. So as you can see here, there's a lot of changes coming over the next few years to our industry. Now, one last piece of regulations that I want to talk about is SNAP Rule 23 from the EPA, which was issued earlier this year. Now, this rule approves, subject to use conditions, 6 new refrigerants for residential and light commercial air conditioning and heat pump applications. And what you're going to notice is that all 6 of these refrigerants, products like R454B or XL41, all have an A2L safety group under ASHRAE Standard 34, which means they all have lower flammability. So you can see that this is the direction our industry is going. And knowing this, it's a good time to become flammable with the new A2L refrigerants. So with that, I want to cover a little bit of background on these products. Now, when the industry first started looking for replacements for the HFC refrigerants, they quickly realized that there aren't non-flammable replacement solutions for many of the different applications out there. So the goal with the development of A2L refrigerants was to try and match the performance of HFC refrigerants as much as possible while minimizing the risk associated with flammability. So how do A2L refrigerants compare to the A1 HFCs? Well, in many ways, they're very similar. First and foremost, they have similar pressure temperature profiles. And I'm showing an example of this here comparing R454B to R410A. And as you can see, they are very similar. But they also have similar thermodynamic properties like capacity and efficiency, similar material compatibility with metals and elastomers. They generally use the same types of oil and use similar system architectures. So all of this is good news for equipment design. That said, how are A2Ls different? Well, that really comes down to flammability. Now, a lot of people refer to A1 refrigerants, myself sometimes included, as non-flammable. But technically, the one flammability class is no flame propagation. But that said, even A1 refrigerants, like R410A, can combust and burn if you expose them to a flame or extremely hot surfaces. Now, A2Ls, on the other hand, do exhibit lower flammability, and therefore they will propagate a flame. So what exactly does lower flammability mean? Well, we can start by looking at refrigerant flammability classes, and these come from ASHRAE 34. Most systems out there use Class 1 refrigerants, which are no flame propagation, and these are products like the baseline HFCs or CO2. But there's also growing use of Class 2L lower flammability refrigerants like R454B or R1234YF. And we're also seeing increased use of higher flammability Class 3 refrigerants like hydrocarbons, such as propane and isobutane. Now, believe it or not, there is actually widespread use of Class 2L and Class 3 refrigerants globally. This is typically in small charge, self-contained applications like window units, car air conditioning, or domestic refrigerators. However, with the move to lower GWP, we expect to see an expansion of the use of these products into a broader range of larger charge size applications. And that has some implications for equipment design. Now, how different are lower flammability and higher flammability refrigerants? Well, we can start to see that when we look at the test that is used to determine refrigerant flammability and flammability limits, the ASTM E681 test. Basically, you fill a globe with a concentration of refrigerant, and you use a high energy electrical source to create a spark to see if you can ignite the refrigerant and see if it propagates flame. And if you get flame spread greater than 90 degrees, that typically indicates flammability of the refrigerant. So this is an example of a Class 1 refrigerant tested under this apparatus. And what you can see is the flame spread is just shy of 90 degrees in this case, so this is Class 1. And here we have an example of a Class 2L where the flame spread is just over 90 degrees. Now, looking at these pictures, they look very similar, and you might think this is a subtle difference, but that 90-degree angle is the demarcation between whether or not a refrigerant can propagate a flame. So it is an important distinction. That said, when you look at the behaviors of Class 1 and Class 2L refrigerants under this test, they look very different from Class 3 higher flammability refrigerants, which are much more energetic, the flame spreads more rapidly and fills the globe. Now, this difference in flammability has a big impact on equipment design. And we can start to get a sense of that when we compare the flammability parameters of these refrigerants. And in the example I'm showing here, I'm comparing an A2L, Opteon XL41 or R454B against an A3 propane or R290. And when we look at the primary flammability parameters, we need to focus on the risk trends to really understand what kind of differences are being shown here. So when we start with the lower flammability limit, or the LFL, this is the minimum concentration of refrigerant in air needed to propagate an ignition. And if we look at the A2L versus the A3, the LFL is roughly 8 times higher. And that can have a big impact on risk, because as the LFL of the refrigerant goes up, you need to leak out a lot more refrigerant or have significantly higher leak rates to form a flammable concentration. Now, once you get a flammable concentration, then you need to be concerned about ignition sources. And that's where your minimum ignition energy, or MIE, comes into play. The MIE of propane is relatively low. It's 1/4 of a millijoule, and hydrocarbons like propane can be ignited by relatively low energy ignition sources like static electricity. But the MIE of A2Ls are typically orders of magnitude higher, and again, this is an impact on risk, because as minimum ignition energy increases, there are fewer things out there that can ignite your refrigerant. Now, assuming you did get a refrigerant ignition, then you want to pay attention to burning velocity and heat of combustion. And here you can see that the burning velocity and heat of combustion of the A2L are significantly lower than the A3, and again, this impacts risk. When you have lower burning velocity, the flame propagates more slowly and weakly and may have difficulty sustaining itself. Where with a higher flammability refrigerant with higher burning velocity, the flame can propagate rapidly, leading to increased rates of pressure rise. Also, when you look at the heat of combustion, the lower heat of combustion means less heat is given off it when the refrigerant burns. So when you look at the combination of lower burning velocities, lower heats of combustion, this can again lead to lower risk as you generate lower severity ignition events. When you put all these factors together, you can see that the more favorable flammability parameters of A2Ls can help reduce the risk in going to a flammable refrigerant in your equipment designs. Now, there's been a lot of industry research on A2Ls, and I just want to cite one example here, which is the AHRI 8017 study. This study looked at ignition sources in the home and their ability to potentially ignite A2L refrigerants. And these are what I would call classic ignition sources, things that might be able to ignite a natural gas leak in the home. And when they looked at these ignition sources and tested them against the A2Ls, what they found, most of them could not ignite these products. Things like space heaters or hair dryers, cordless drills, light switches, plugs and receptacles, or cigarettes could not ignite the A2Ls. There were some things that did, like hot wires or safety matches, but most potential ignition sources in the home would not ignite these products. So, to wrap up overall, when we think about the flammability of A2L refrigerants compared to higher flammability A3 products, what we find is that the A2Ls are less likely to form flammable concentrations because of their higher flammability limits, and this enables us to use larger charge sizes in larger applications. The A2Ls are also harder to ignite by virtue of their higher minimum ignition energies, and this makes them safe to use with many commonly used electrical components. And finally, A2Ls are less reactive and have lower combustion energy, which means that they typically will generate lower severity ignition events. Now, there's a lot of information on A2Ls and their behaviors on our website, opteon.com, and there's also a Burning Truth campaign that we're running. I've included the link here below that you can check out at your leisure. And with that, I'm going to turn it over to you, Allison.
Thank you, Stephen, for that thorough grounding on A2L properties. Hello, everyone. I was going to say good afternoon, as it is here in Delaware, but I see we have participants ranging from Seattle all the way to Switzerland, so I'll say good morning and good evening and just about everything in between. It's really nice to be here speaking on behalf of REAM to all of you. Stephen shared a lot of important information on comparison of refrigerant safety classes. As you can all imagine, a lot of refrigerant comparison has occurred for OEMs in these years leading up to these imminent regulations. And despite the many similarities between A1s and A2Ls, a lot of work goes into preparing an entire industry of equipment for such a change. Many of you are undoubtedly still dealing with this shift from R22, so you know what we're up against. So let's talk about how we got to this point. There are many considerations for an equipment manufacturer when selecting a refrigerant replacement. Key selection factors are global warming potential, of course, performance, efficiency, and similarity to the incumbent refrigerant in terms of design elements and manufacturing. These factors ultimately affect the applied cost of the system and the amount of development effort and time, for example, the number of test cells that need to be used for testing and rating products. Our R&D and sourcing teams had to look at component availability, particularly for compressors, both scroll and rotary compression systems. They had to look at refrigerant sourcing and locations, logistics, making sure there'd be adequate supply to our plants. And then, of course, there is the long-term consideration, making sure there's future viability of the refrigerant solution, one with a long regulatory runway. After comprehensive R&D evaluation, testing, and analysis spanning several years, considering the many selection factors, Rheem arrived at the decision that R454B is its selected refrigerant to replace R410A in current ducted residential and light commercial air conditioning lines in North America. As we heard, R454B is marketed by Chemours as XL41 in their Opteon line of low GWP refrigerants, and they've done a lot of work with industry partners, such as component manufacturers, to ensure adoption goes smoothly. Regulatory agencies recognize that a 750 GWP limit allows preservation of efficiency and performance for air conditioning, avoiding a complete major technology overhaul that would come with a lower limit. And the primary alternatives below 750 are R454B and R32. We've already seen news of major manufacturers selecting one or the other, so we know that we're headed for a two-refrigerant future. And before anyone groans about that reality, we should probably remember that our friends on the refrigeration side of the business have it much worse. So let's talk about how these two main choices for air conditioning lined up for Rheem. Both R454B and R32 are similar to 410A and have comparable replacements in many respects. Both fluids meet the expected regulatory threshold of 750 for AC. Both are similar to 410A from an equipment design standpoint. Both require slightly less refrigerant charge and can therefore result in lighter equipment. And they're both available and used today globally. There are a few differentiators, however, that Rheem took into consideration and ultimately tipped the scale. For example, the discharge pressure of 454B is lower than that of 410A. The discharge temperature of 454B, while it's slightly hotter than 410A, it's not as hot as R32, and discharge temperature happens to be very important for heat pumps. To maintain the same operating envelope of the equipment, design changes in the compressor may be necessary to account for the higher discharge temperature of R32, and a change in compressor lubricant may also be needed if using R32. And then, of course, the GWP number itself is something to consider. GWP is critical from a sustainability and climate standpoint, as we all know, but also we know that via AIM, HFC phase down and limits on production quota mean there could be an effect on price and availability of higher GWP fluids, as we've seen happen already in Europe. This tells us that every GWP point could matter in the future, especially if you're using large volumes. In summary, considering the technical evaluation, sustainability, long-term viability, and importantly, the comfort resulting from high-performing and affordable product with best cost to consumer, Rheem ultimately decided to go with R454B. The question is now, when will we see these products on the market? If we step back 18 to 24 months, California was hot on the trail to enforce A2L requirements as early as 2023. But updates to building codes and standards were not quite ready to facilitate the early transition. So now California will be joining the rest of the country, at least as it relates to air conditioning, as we move to a national phase down triggered by the AIM Act. At REAM, we will take a leadership position in this transition by being ready with select product families in R454B as early as late 2023 or as codes allow. Launch timing of models for certain regions will be limited by state building codes, but hopefully all the state codes will be ready by 2025, and we'll touch on more about that in a bit. Anyone who's in R&D or engineering can attest this is a multi-year process to plan for such a sweeping transition, regardless of how similar the replacement is to the incumbent refrigerant. And this comes immediately after a major change in energy efficiency requirements from the Department of Energy. So now let's talk about some of the main differences you'll see between 410A and 454B equipment designs. We still have a ways to go before A2L systems are fully mainstream in the market, but I can certainly tell you a little bit about where we're headed and how we got there. As you will know, and I'm looking at you virtually, distributors and wholesalers, we don't just have a refrigerant change to consider, we also have the change to minimum efficiency standards and metrics for HVAC. That's two major changes for equipment within 2 years, which is unprecedented. I've compared this to having two Cat 5 hurricanes hitting us back to back. Not to mention the shift in listing standards from UL 1995 to UL 60335-2-40. REAM is developing its full residential and light commercial platform to comply with the new 2023 efficiency standards, which represent about a 7 to 10% increase in minimum efficiency, making technology upgrades to optimize the system to best manage impact of cost and size, maintaining key features such as serviceability. But we can't just look at efficiency changes in a vacuum. Taking a strategic long-term view, REAM is designing for the DOE efficiency changes with A2L in mind. So products launching in the new platform will be able to transition most optimally and with a very similar footprint. Much of the guidance for designing to use flammables comes from our safety standards. These are important new requirements in the newly updated standard UL 60335-2-40, with the 3rd edition published and the 4th edition underway, and also in SNAP Rule 23 that Stephen mentioned earlier. In particular, most of these standards updates focus on mitigation and the safety measures designed to prevent reaching that flammable concentration in air and ultimately an ignition event. We have safety features such as leak detection, where if the refrigerant charge exceeds a certain limit, then the leak detection system would engage mitigation by turning on the blower at the highest speed, dispersing any leaked refrigerant to avoid concentration in a small area. The charge size threshold that requires leak detection is based on the lower flammability limit and is approximately 3.9 pounds for 454B. So since most residential systems will have a charge size that meets that threshold, they will require leak detection on most of those systems. You also have minimum room area for installation, which for consumer products like your room air conditioners, your small portable items, those will be noted on the equipment labels themselves. For your traditional ducted AC and heat pumps, the tables from the standards will be included in the manufacturer's I&O, the installation and operation instructions, and will aid the installer to determine the installation limitations, so that way you have no burden of additional calculations that you have to perform at the job site. Safety interlocks are also incorporated, and there's new labeling and markings required on the unit, with some examples shown here on the slide. Your service valves and ports will also be colored red. In general, we're looking to minimize opportunities for leaks, and we're looking to minimize the total refrigerant, even for small package systems, for safety and sustainability. Some additional design changes to be aware of. You have components. They've been specifically qualified for 454B, and our engineers have worked with these suppliers at length. The compressor, for example, has larger displacement than a 410A compressor because the refrigerant has slightly lower volumetric capacity. The expansion valve is optimized for 454B. Electrical components are approved for use with A2L refrigerants, and the charge size is optimized for best performance in both cooling and heating mode. The key takeaway here is that with all of this optimization for 454B, these components, while similar, are not interchangeable with those on a 410A system. Now that we've covered some of what's changing from an equipment standpoint, let's focus on what installers and service technicians need to know, and Stephen will get us kicked off on that topic.
Thank you, Allison. It's a lot of great information. So I want to start out with some ground setting, some basic principles that you should be aware of when working with flammable refrigerants. First and foremost, only use a flammable refrigerant in equipment specifically designed for it. You don't want to use an A2L refrigerant in a system designed for an A3 or vice versa. And you don't want to use an A2L in a system designed for another A2L unless it's rated for both. There are some key differences between, A2L refrigerants from one to the next, and these have implications for system design, such as what the refrigerant charge is. Additionally, when you're doing your installations, you want to make sure that your systems are in compliance with relevant safety standard and building code requirements. Now, this is an area where many technicians may not have paid a lot of attention in the past, but we're going to have to be a little more aware of going forward. The good news is there will be a lot of information in the manuals you get from the equipment manufacturers that will help you stay in compliance. And also, you never ever want to use a flammable refrigerant like an A3 or an A2L to retrofit a system designed for an A1 refrigerant like R410A. That can create unsafe conditions. And we've seen this in the past in our industry where people, sometimes unknowingly, put a highly flammable refrigerant like a hydrocarbon as a retrofit into an R22 system where you had fires and accidents occur. You always want to make sure you're using the refrigerant in a system it's designed for. Now, for installations and service, you want to make sure you follow the OEM instructions. The OEMs will be providing manuals with a wealth of information that will help explain changes to the equipment and changes in installation procedures. And this is really a good place to get started with familiarizing yourself with the differences in equipment design. You also want to make sure that you're using appropriate service equipment tools and working conditions and procedures for flammable refrigerants. Now, the good news is a lot of your common hand tools that you use with A1s will be just fine on A2L systems. You don't need to run out and buy a whole new set of non-sparking beryllium hand tools. That's not necessary. But some of your electrical tools may be different. And when it comes to working procedures, you need to be cognizant of your surroundings, control the work area. You want to revisit or strengthen your commitment to best practices. Best practices have always been a great idea, but whereas before they were often recommendations when working with A1 systems, in many cases they will be mandatory now going forward. Things like proper recovery and evacuation of the refrigerant from the system, pulling a good deep vacuum, doing pressure checks on your installations, checking superheat and subcooling. All these things are going to be critical going forward. Now, one of the things you're going to find is that flammable refrigerants tend to be odorless. This is different from, say, natural gas in the home or propane in your gas grill. Those fuel sources contain stenching agents, where if you have a leak, you smell a strong sulfur or rotten egg odor to help alert you. You're not going to see that with flammable refrigerants, even with refrigerant grade propane. And the reason is that these chemicals, these stenching agents, have some corrosion and compatibility issues with the materials of construction in air conditioning and refrigeration systems, particularly in the compressors. And they also can be readily absorbed into the compressor oil or the desiccant in your filter dryers, which renders them ineffective in the system. So when you're looking for leaks on systems with flammable refrigerants, you want to make sure you're using appropriate leak detection. You want to make sure you're using handheld sniffers or fixed detectors that are rated for the refrigerant in question. And there are plenty of A2L rated models out there. Now, soap bubbles, they are a tried and true method that worked before, and they will work again because they work off of pressure. And they don't care whether the pressure is coming from an A1 or A2L. That said, you never ever want to use an open flame like a torch or a lighter to look for leaks on a system with flammable refrigerants. One last area I want to touch on is refrigerant cylinders. Whether it's disposable cylinders, refillable cylinders, or recovery cylinders, you're going to encounter differences when working with A1s and A2Ls. Cylinders for A2Ls will have either a red band on the cylinder or a red top to indicate that they're intended or they contain a flammable refrigerant. You also may see labeling indicating a flammable refrigerant as well. Now, disposable cylinders for A1 cylinders have a rupture disc in case the pressure in the cylinder gets too high. The rupture disc opens and releases the refrigerant. However, disposables with A2L refrigerants will not have a rupture disc. They will instead use a resettable pressure relief valve. And the reason for this, if you have the cylinder in the back of your van and the pressure gets too high, you don't want a rupture disc to release the entire contents of a flammable refrigerant in the back of your van. Instead, the pressure relief valve will pop and release just enough pressure and then reset itself. Now, if you need to discard a disposable cylinder with an A2L refrigerant, just like with A1 refrigerants, you want to make sure you're following proper guidelines like AHRI Guideline Q, where you make sure you recover all the residual refrigerant, pull a good vacuum, and use an appropriate tool to puncture the cylinder. Now, you don't want to try and remove the pressure relief valve from an A2L disposable cylinder. It's not that it's unsafe, but it's very hard to do. So puncture the cylinder with an appropriate tool instead. One last area I want to touch on, we already mentioned earlier about the EPA ban on disposable cylinders that's going to start going into effect January 2025. And that's primarily to address illegal imports, but there are a number of other concerns when it comes to refrigerant and refrigerant cylinders that our industry has had to deal with over the last several decades. Things like counterfeit refrigerants, where you have a different refrigerant, sometimes hazardous chemicals in the cylinder, or lower quality refrigerants out there. Now more than ever, it's important to make sure you're buying your refrigerants from trusted, reliable suppliers. And the EPA will be implementing tracking of refrigerant cylinders going forward in the future. I believe in 2025, things like QR codes to help track the refrigerant from the time of manufacture throughout its usable life. And with that, I'm going to turn it back over to you, Allison.
Thanks, Stephen. Along the lines of refrigerant handling, you may already be thinking about service practices and tools. Many of the same service items can be used for systems with A2L refrigerants as can be used with R22 and 410A systems. However, some service equipment, due to the electrical components and motors, should be specifically designed for use with A2Ls. Installers and technicians will likely need at least some new equipment, gauge sets, recovery machines, and leak detectors, for example, in order to work with newer refrigerants. Many of your tool manufacturers are already offering A2L qualified products. Vendors such as Appian, Navac, Fieldpiece, Infinicon, Yellow Jacket, and I think there's plenty others. Sorry if I missed any. We encourage you to reach out to them for more info directly. You'll want to check with your vendor on what they have available for the new refrigerant, especially if you're replacing a piece of service equipment in the near future. Even though this change we're talking about is still some years away, it makes sense that if you need to upgrade now, if you need to replace now, upgrade it so that you don't have to replace it again to work on an A2L system in the coming years. And while we're not diving into it here, we do expect that for A2L refrigerants, much of the storage and transportation requirements are going to be similar to what we had for 410A. A really good place to go for more information on this is the Safe Refrigerant Transition Task Force within AHRI. Stephen and I both participate in that task force, along with a lot of other industry members. And they have a website chock full of good resources and a newsletter for new info and updates. So please check that out. As the advent of A2Ls in residential systems approaches, technicians will see service details outlined in certification exams and study guides, some of which are already launching. In fact, I think I saw a comment that someone just got their A2L certification, so bravo. And certainly there's a lot of training already available from organizations such as ACA, RSES within the ESCO group, and plenty of others. So the key here is preparing early. Detailed instructions will also be available from the compressor manufacturers and in the OEM service manuals. And yet, with all this new information, some of the traditional guidance remains very common sense. If nothing else, remember that when beginning work on a system, you should always monitor for flammable gas concentration, ventilate the work area, and eliminate sources of ignition using your service tools that are approved for use with A2Ls. REAM is incorporating sessions dedicated to A2L equipment as part of its comprehensive training program for installers, releasing training in 3 phases. And I think phase 1 is already out. Phase 2 will be out by the middle of next year and will incorporate some basic refrigeration principles and best practices. Phase 3 will incorporate the specific REAM product technology as it applies to A2L. As mentioned earlier, we still have more work to do to be ready for 2025. And what does it take to shift an industry to flammable refrigerants? For stationary applications, it takes 3 main things. Number 1, a regulatory driver, which we now know will happen under AIM and is likely to be 2025. So we can put a big check mark next to that. Number 2, we've got EPA SNAP approval, with SNAP being the clearinghouse for refrigerant replacements by application. Stephen talked about this in his regulatory portion, that EPA completed the rulemaking on this in April and officially approved 454B as a replacement in air conditioning. So that's complete as well. Number 3 is building codes. In order to install appliances containing flammables in buildings, codes must be updated to allow it. You'll notice there's no check mark there. So when will that happen? Here's the major catch with these and what's important for all installers to know. Even though national model codes are currently being updated and should be available by 2024 at least, local building codes still need to be updated individually and either adopt the model code or adopt language from the standards directly into the local code. This is a state by state and sometimes even county by county process. And we're only about, I'd say, 1/3 of the way there for air conditioning. I can't emphasize how important this is, and you may be called on to be involved. And you might think, well, what's the big deal? If there's no change, there's no code, then there's no change, right? No good. We must get this done so that you have compliant product able to be installed in your area, and we can shorten the transition burden to the extent possible for everyone involved. So that concludes the presentation portion of the webinar. Stephen and I would again like to thank you for listening, and we'll turn it over to Kyle to kick off the Q&A.
Absolutely. Thank you, Stephen and Allison. A great presentation. Now we'll have our presenters address a few questions like we mentioned. First one up here. What are the PPE requirements for A2L refrigerants?
I'll take that one, Kyle. I mean, essentially, they should be really the same as they are for the A1 refrigerants. You want to make sure you use appropriate eye protection, use gloves to prevent frostbite, the same recommendations that we've had for refrigerants for decades.
All right. Someone else asking here, will I still be able to braze?
And I'll take that one. Yes, there is no elimination of brazed fittings as a result of this change. So that will be able to continue. You just need to follow precautions in the safety standards and the manufacturer's installation instructions.
All righty. I think R454B has a temperature glide. Can it still be topped off after system leaks?
So I'll take that one, Kyle. So R454B, like R410A, is a low glide refrigerant blend. So yes, the impact of fractionation from leaks should be small. So you should be able to repair the leaks and top off the charge.
All right, Michael's asking, where can I go to get the A2L certification?
So you want to take that one?
I'll take.
I think there's a number of certification programs.
Sure. So there are several organizations that do have A2L certifications out there. We talked about a few of them earlier. I know ESCO has an A2L certification. ACA, I believe, has A2L training and or certification. RICS is working with ESCO. NATE has Flammable refrigerant certification for A2Ls. And then you're going to see training coming out from additionally from the equipment manufacturers and the refrigerant manufacturers too. So there's going to be a lot of different options out there for getting training and or certification.
All right, and Stephen, this might be another one for you. What is the flame spread angle of R410A and R134A?
So they're safety group A1 or class 1 flammability refrigerants. So the flame spread under the conditions for ASHRAE 34 that we were talking about should be less than 90 degrees.
Okay, next question from Dudley. I think this one's for you, Allison. Can R454B be a drop-in replacement for R410A systems already in use?
That's a great question. I'm glad somebody asked it. This is not something that is even 454B specific. The standards and especially SNAP Rule the Rule 23 prohibit the use of A2Ls as a retrofit substitute in equipment designed for A1s. So by the standards, this is specifically prohibited. So it doesn't matter which A2L it is. It cannot be a retrofit product. And I know that's unfortunate news for many of us out there, but that is the reality.
Okay, another one for you here, Allison. So if a leak does occur in the residential system with a flammable refrigerant, what would be the proper procedure to potentially stop a fire if the refrigerant does catch flame or combust?
Well, I think, that one is probably not, specific to the equipment, but more first responder best practice. And so I would defer to those experts for that type of question on, fire, event handling, and certainly they would be the experts in that field. But I think those are great questions to ask if you're, concerned about responding to an event, a safety event.
Okay.
So just to add to that a little bit, the safety standards and the equipment designs based on the safety standards are all around prevention. Preventing a flammable concentration from forming in the first place by using mitigation and things like, limiting charge based on the room area, using leak detection, circulation, air, and other techniques are all designed to prevent a flammable concentration or ignition event from occurring.
Okay, next question here from Chris. Can you explain the ignition difference between A2L and A1? Maybe you take that one, Stephen.
If you're talking about the ASTM E681 test, basically when you use the electrical spark to see if you can get an ignition, um, you might get some flame spread with an A1, okay, but the flame spread should be less than that 90-degree angle. For flammable refrigerants, whether it's an A2L, A2, A3, the flame spread will be greater than that 90 degrees.
Okay, next question here from Rick Black. Will Rheem and other manufacturers provide service valves that are brazeless friendly? Currently, it's very difficult for contractors to use brazeless technology options with existing service valve connections.
Oh, that's a really great question. And I know, there's the popularity of like press connect fittings is increasing. So, but that's some of the feedback that I can take back to the design team is make sure that it's friendly to the brazeless fittings, since that is something that is becoming more and more prevalent. So thanks for asking that.
All right, Sam's got one here. I'm hearing about an R466A that has similar pressure temperature profile to R410A, but is under 750 GWP and is classified as A1. What are your thoughts about this refrigerant? Maybe take that one, Allison.
Sure, no problem. And this is another good question because obviously, if you can get compliant and not have to make the changes to shift to flammable, wouldn't that be ideal? But Rheem certainly looked at 466A, and as it became clear that that would not become commercial in time for the regulation, with resolving all aspects of, say, thermal stability and material compatibility, plus with the GWP simply being higher, even though it's under 750, it was ruled out, during the vetting process.
All right, this next one's from Terrence. Stephen, I think it's for you. Will A2L certification be required similar to what we had with R410A?
So I think what you're going to find is that might be up to equipment manufacturers. And what I mean by that, I'm not aware of any regulation requiring certification, but previously with R410A, some manufacturers required R410A certification to purchase and work with their products. So it's possible we might see that going forward.
Okay, I think this next question here from Connie is directed at Rheem. Just to clarify, you will be introducing some products to market by 2024?
Yeah, I think what the our product team had indicated is that they would have some models in development and available towards the end of 2023. But again, this is highly dependent on where they could be installed in what region and, for certain models. So definitely stay tuned for more information from Rheem on those specific product launches, because we'll be getting that information to distributors and wholesalers.
Okay, another one for you, Allison. Will the leak detection system come from the factory or purchased separately?
Great question. So the answer is sort of both. So your leak detection system that's part of the equipment will be incorporated into the equipment itself. It's not something that's field installed. It will be shipped with the equipment already part of it. However, there's such thing that, a lot of the surface technicians know they use as handheld leak detectors. And certainly those can be procured and you should be used routinely in service. And so they'll be available separately as well.
Okay, Steve, I'm going to bring you back in here. If disposable cylinders will no longer be used, what will the manufacturers use?
Well, the industry is going to have to transition to refillable cylinders. I mean, the idea of disposable cylinders, you use it once and they're done. And we've had refillable cylinders for the larger types of cylinders and for recovery cylinders for some time. So that would be the direction our industry is going to go with the smaller sizes as well.
Okay, another one for you here. Could R454B accumulate enough in a closet from a coil leak to cause a fire hazard?
So this is similar to what I mentioned earlier. The safety standard is intended, it's really focused on prevention. The idea is to prevent a flammable concentration from forming in the first place. So if the equipment is working as intended, you shouldn't have a flammable concentration form.
Okay, back to you here, Allison. Will there be new electronic leak detectors made available with these changes, or will there be another method that will be advised?
So the leak detectors, again, talking about handheld leak detectors, so you can purchase these directly from your well-known vendors of service HVAC service tools and instruments. The handheld leak detectors using infrared technology may be a better option to use with flammables compared to the electronic leak detectors. But this is where, again, you should definitely check with your local supply house and your manufacturer of your service tools and select what they would recommend as most appropriate for your handheld.
All right, next question here. Would you care to comment on the efforts in the EU to push for propane in RAC?
Oh, well, yeah, RAC, right? That's room air conditioner. So these are going to be your smaller systems. These are, considered sometimes self-contained, very small charge sizes. So, we already know that, hydrocarbons can be used in like your small beverage coolers and things like that. So I think we will see, it used where it can be used below the charge size. Just the allowable charge size is just so much lower than that of an A2L. So it really has to be for those really small units. But Rheem has the Friedrich line now of the room air conditioners and dehumidifiers and their smaller systems. And so, there are some more options that can be considered for use there. Certainly that would be one of them.
Okay, and last question here is from Bob, and it's for you, Stephen. Which oil is approved for 454B?
So that's going to go back to the compressor manufacturer, but 454B is being used with both POE and PVE oils. In fact, some major compressor manufacturers have said they're using the same exact oils that they use in their 410A compressors with R454B.
All righty. Well, a lot of great questions, a lot of great answers, but we are out of time. Please join me in thanking Stephen and Allison for the presentation, as well, of course, our sponsors, Chemours and Rheem. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. As you exit today's webinar, please take a couple of minutes to complete our survey. We strongly welcome your detailed comments. You can also visit achrnews.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience. Enjoy the remainder of your day, everybody.